Assume that a sample is used to estimate a population proportion P. Find the 98% confidence interval for a sample of size 283 with 190 successes. Enter your answer as an open interval using decimals, not percents, accurate to 3 decimal places. Okay, well, answer should be obtained without any preliminary rounding. However, the critical value may be rounded to 3 decimal places. Okay, so what we want to find is a confidence interval, a 98% confidence interval for a population proportion. Now, the calculator can do this for us. It will do it through a function called 1prop zint. And it's pretty easy to use. What we do is press the stat key, go over to tests, and you scroll down until you see 1prop zint. So there it is. Now, with 1prop zint, we have a couple of values that we need to input here. So we have n, which is our sample size, and we're told here we have a sample of size 283. X is the number of successes out of that sample, so in this case it's 190. And then the level of confidence, we're told to use a 98% confidence interval, so my level of confidence is 0.98. When you hit calculate, you are given the endpoints of those intervals, so 0.606 and 0.736. And that right there is in the form of an open interval. So that would be your final answer if you're allowed to use the calculator to that extent. If you need to use formulas, then follow along. Otherwise, you don't need to go any further in this video. For formulas, what you need to do to get a confidence interval is take your point estimate p hat plus or minus a margin of error. So p hat is pretty easy to get. You take your number of items that favor your event divided by the number of items in your sample, and that'll give you the value of p hat. So 190 divided by 283 in this case, that's, we'll say 0.67. Just take it to 2 decimals. It's said to not use any preliminary rounding, so in that case, take some more decimal places. That'll be fine. Usually it doesn't make a whole lot of difference. Next, we need to find our margin of error. To find this margin of error, we need to take our level of confidence and find a critical value based off of that, and multiply it by the square root of p hat times q hat divided by n. So the level of confidence per our, or the critical value per our level of confidence, there's a formula which is the absolute value of the inverse norm of 1 minus the level of confidence divided by 2. Now, in this case, I'll get my calculator out here. Our level of confidence is 0.98. So if I take 1 minus that, so 1 minus my level of confidence divided by 2, then that gives me 0.01. Now, I need to do inverse norm. So second invars gives me the distribution menu over here to inverse norm. And the area that I need to input here is 0.01. All right, that's the area to the left of the score I'm interested in. Mean and standard deviation, just leave as 0 and 1 for a standard normal distribution, that is. And if you didn't see this menu pop up, just type in 0.01 and that's fine. All right, so inverse norm of 0.01, we should all get at this point negative, well, positive, we'll change it because it's absolute value, 2.33. All right, so my margin of error then is 2.33 times the square root. P hat is 0.67, and Q hat is the complement of that, so 0.33. So 1 minus 0.67, that is. N was 283. We just need to type this into the calculator. So 2.33 times the square root of 0.67 times 0.33 divided by 283. So that's 0.065. Now, that is my margin of error. So to come up with a confidence interval, all I need to do is take the value of p hat, where is that? Right there, 0.67 minus that margin of error, and then 0.67 plus that margin of error. All right, so if you'll notice, I am off by a decimal value. So originally I had 0.606 instead of 0.605. And that's just rounding error. That's what is said here by not doing this with any preliminary rounding. Well, you can't really do it without any preliminary rounding unless you change the formulas around accordingly. So you have to choose some level of rounding. So just if you're doing it with formulas, perhaps give 4 decimals for p hat, and maybe try and use your inverse norm value to 5 or 6 decimal places. Just use some more decimals, and that'll agree to 3 decimal places in the end. But that is how you would go about it through formulas, and you should get the same result if you use formulas or the calculator exclusively.